In this section, we're going to be looking at how we use H3 to aid in our aggregation and mapping of the data. Firstly, let's look at this bit of an explainer at H3 indexing. We can actually use a Polars plugin here, Polars H3, to perform the indexing for us. This keeps it nice and efficient, and we don't have to get out of the Polars ecosystem in our code, keep everything nice and reliable. The lat long to cell is the command that we need. We simply have to specify which column contains the latitude information and longitude information, what H3 resolution we want to actually index at, as well as the return type. We opt for the string return type here as it plays much more nicely with the other packages that we use, mainly the mapping package for Pydeck. If you're seeing you're having errors and you haven't specified the return type, the default is the int64 encoding of H3, and that tends to not be used as much by the other interoperable libraries. For the mapping, there's two components. Pydeck works with the concept of the deck, which is the map, and the layers that you want to represent on top of the map. They're simply generated using the layer and deck objects. For the layers, we specify that we want a H3 hexagon layer, and all we need to do is give it the information. Unfortunately, we have to translate into pandas here, although that's not too much of a compromise, and we have to specify which column contains the H3 index. For the most part, that's going to be just H3 index, as that's what we pre-indexed the data to. Finally, when we want to actually show the data, we simply plug in the layers to the deck or the map, and we hit show. So here's the first example plotting the entire spatial extent of the Seagrass dataset. We can see that we're using the entire data frame. We're aggregating by the H3 index, and then we're wanting to know how many records are there given each index cell. We're aggregating on that number of records, specifying how many quantiles we want, so what's the distribution of the color mapping, and which palette we want to use. Finally, we plug our layers into the deck and show it. This gives us this representation of our data. We can see that there's a nice spread all around Australia, and some clusters where there's much more data available. Another way we might want to restrict our regions and index our information is via the Australian Marine Regions tags. Now these are tags we've added because the H3 index is not particularly easy for a human to understand. It's quite abstract. These replace that kind of concept with a simple string match. There's many regions available. You can see them all in the table here. And to get a bit of a look at them, just head to the Explore URLs. Here's an example below. We're looking at the Commonwealth Marine regions. You can see these are regions that surround Australia. And they have simple names like Northwest or Southeast. These become the tags that we can search our data and filter by. The tags themselves have a little bit of structure to their encoding, which can be useful. So we can see here that for the Commonwealth Marine regions, that comes first, followed by the actual region itself. So in principle, the formula of our tags are the type, some optional super regions, and the region itself. So you can see this most complicated tag at the bottom has the type IMCRA, followed by these optional super regions, the provincial water type, and then the region itself, the cold-temperate waters. So let's see what tags are available to us in this dataset. We can see here, if we just explode the Australian Marine Regions tags column, all of the available tags and how frequently they occur. So at the very top here, we have this tropical waters. Most of the data we have seems to be sitting in this tropical waters kind of area. We can filter to a particular marine region with a simple string contains filter. So you can see here we can take our entire data frame and filter where the string of the Australian Marine Regions column contains the IMCRA provincial water type tropical waters. We have our similar mapping and aggregation that we have to do for every map. And let's look at the resulting data. You can see here that everything that's in tropical waters has been kept, and all of the things which are in the other regions around Australia have been filtered out.